Hi everybody, good morning, good afternoon, and good evening. Hi everybody, good morning, good afternoon, and good evening. Thank you for attending today's Zmanda webinar. My name is Jason, and I'll be your host today as we learn more about simple and cost-effective disaster recovery leveraging cloud services. When I'm not hosting webinars, I'm responsible for Zmanda's sales development and lead generation activities, and I look forward to working with you and following up with any information following today's event. I will now introduce our speakers. We are pleased to have Lauren Whitehouse with us today. Lauren is a prominent analyst in the storage industry who will share her perspective of cloud computing on data protection. Welcome, Lauren.
Hello, everyone.
I'm also pleased to introduce Chander Kant, CEO of Zmanda. Chander has been involved with cloud storage from its inception, and Chander will be sharing his experiences with us of building cloud-based disaster recovery solutions for various Zmanda customers. Welcome, Chander.
Hello, everyone.
Great. Again, welcome, everybody. Thank you for your time. We appreciate it. And without further ado, I'm going to hand over the presentation to Lauren.
Great, thank you. Hello, everyone. As you heard, I'm an analyst with Enterprise Strategy Group. And just to give you some context, Enterprise Strategy Group is an industry analyst and consulting firm. We're based on the East Coast of the United States, and we work with a lot of vendors and talk to a lot of end users on a regular basis. And I happen to write a lot about the data protection space. So today we're going to be talking about disaster recovery in the cloud. So cloud computing and storage are enabling companies of all sizes to implement alternative data protection strategies. So one of the more compelling trends that we're seeing is to provide a cloud-based disaster recovery model that is a lot more cost-effective than implementing a one-to-one, physical-to-physical, computer-to-site type of disaster recovery model that many organizations think that they would have to have. So today I'm going to share some information about the business risks associated with downtime and how to mitigate them. And I'll cover some of the basics of protecting data with cloud backup approaches. So businesses are subject to an interruption of operations resulting from some type of event. So typically you see things like viruses or hacking events, power outages, natural disasters, operator errors, an upgrade or a technology refresh where you might have made a mistake along the way and have to revert to a previous point in time. So it's important to note that all of these types of disruptions that you might experience are not necessarily natural disasters, such as fires or weather-related events, but the disruptions can be caused by some pretty mundane events, such as the unintentional or intentional error for a critical system in the environment. For the two main classes of interruptions, the catastrophic events happen less frequently. And again, as I said, it's typically those mundane nuisances that happen at a higher frequency. However, the naturally occurring disasters are often the anxiety-producing reminder that any type of catastrophe could strike, and businesses should be prepared for the worst. If we look at just what occurred in 2010, we've seen record-breaking snowfall along the east coast of the United States, an earthquake in Haiti, another earthquake and tsunami in South America, flooding in the Midwest of the United States. Even the oil spill in the Gulf has been disruptive to a lot of businesses. And then, of course, a recent spate of tornadoes and the Icelandic volcano more recently. So these sort of conventional or unconventional disasters could cause downtimes for organizations. So as companies rely more and more on digital content to conduct business, the tolerance for downtime is going to increase. Organizations use email, collaboration platforms, content management systems, financial applications. You have your corporate website, Salesforce automation solution, just to name a couple of the things that you're probably highly dependent on a day-to-day basis. And without access to these applications and data, you could suffer revenue losses or some other adverse business consequence. So ESG regularly surveys organizations on business and IT issues, and one of the things I'm showing here is the results of a recent data protection survey. This is actually for Tier 1 data in an organization, and what it shows is that the top two bars from left to right, the first two, 56% of the companies with 25 servers or less could tolerate only 1 hour or less of downtime, and another 21% could withstand 1 to 3 hours of downtime. So if you think about what it takes to rebuild a server from scratch and reinstall applications and recover data, potentially from tape or other sources, trying to meet that 1 hour to 3 hour even window is pretty aggressive and probably is not something that most organizations can handle. So if you're the business owner or IT executive, you can probably think of insurance policies that you might put in place or contingency plans that you might have in place to deal with those unexpected situations that could impact your business. Liability insurance, property insurance are pretty standard measures for most organizations. And oftentimes when you look at the insurance policy equation, you're determining the risk of the event and having some adverse effect on the investment cost of that protection strategy. And it's basically going to boil down to math, right? What's the cost of the lost revenue that you might suffer as a consequence of some type of interruption versus the premiums or costs incurred to minimize the risk. So the consequences of that long-term, adverse effect to your business is going to be things like lost revenue, potentially lost customers, employees, or partners. Definitely, you risk damaging the company's reputation. I'm sure we've all had situations where you've had a bad level of service because you weren't able to access something online that you normally would, and it's very frustrating for you as a customer. And then there's also some legal liability depending on the type of industry or business that you're in. So how responsive and resilient is your company today? So if we look at that cost versus risk assessment done for digital assets, we really have to take a couple of things into consideration. Most businesses are going to rely on computer systems to keep their day-to-day businesses running. I gave you a couple of examples of different applications that are most critical. So you have your financial records, employee information, customer data, sales orders. Maybe it's even things like video surveillance or your supply chain data. Tracking your third-party logistics of shipping might be something that you're highly dependent on. And as more and more aspects of your business become digitized and automated, it's even more important to protect those assets. So storing a copy on-site would be a great first step, but having that off-site copy is really the insurance policy that you need to protect yourself from a disaster that might strike your primary location. But where is that off-site location? Do you have a second site that you can leverage as a DR site? How cost effective is it? So here on the next slide, what I'm showing is that 30% of respondents to a recent ESG research report ranked improving disaster recovery capabilities as the top spending priority for 2010. And that's over things like improving application backup and improving the backup of virtual server machines. So this is pretty high up on people's list. So here what I'm illustrating is just a couple of approaches to maintaining an off-site copy for disaster recovery. And these are all cloud-based data protection service models. From left to right, we have software as a service, and this would take advantage of a web-based application and backup data to a cloud storage container. So there's no on-premises technology investment, nothing to manage really on-site. In the middle, we have the hybrid cloud backup model, and that's going to take advantage of software as a service. However, you're going to maintain a copy on some type of local storage appliance or device so that if you had some type of a bulk recovery and you could do sort of a quick operational recovery from the local copy before the cloud copy, that might be helpful. But DR is really enabled by that cloud-based copy. And then finally on the right is an electronic vaulting model where on-premises technology is used for the on-site copies, and then off-site copies are transferred over a WAN connection to a specific cloud container. So overall, these solutions are going to offer, pretty easy implementation because you've got that infinite scale of the cloud storage, ubiquitous access, so I can access my data from any location as long as I have access to my application. And then, of course, that offsite copy for DR, and for a lot of organizations, a higher degree of cost efficiency for disaster recovery. And as you can see, 54% of the research respondents adopted a SaaS model, 21% adopted that hybrid model, and another 25% adopted the electronic vaulting model. So this was another chart from our research report just showing, what are the different sources of data that need to be protected and what cloud backup solution is protecting. So there's obviously a lot of solutions in the market to protect PCs, and many organizations are using a cloud-based backup model. But we see here that a lot of organizations have opted to protect their application servers. About 50% only protect their application servers, whereas another 21% are protecting a combination of application servers and their endpoint devices. So that's a good almost 75% of the market that is taking care of their applications. What motivated them to look for a cloud backup solution? The number one response, both for mid-market sized companies and larger enterprises, was the ability to store data remotely for disaster recovery. That came out number one. Obviously, the other items ranked here by the respondents add weight to the decision, since many of them focus on improving processes and costs. Things like getting a better level of service by outsourcing it or using a software as a service type of model, more cost effective than maintaining all that in-house technology and stuff. That goes a long way in justifying it, but DR definitely is the number one thing. So then, interestingly, just looking at cost a little bit further, I actually took a look at the expenses for disaster recovery, comparing a number of different approaches. So as you see across the bottom, left to right, D2C is disk to cloud or software as a service model. D to T is disk to tape. D to C is I back up to disk locally and then I send a copy off to the cloud. And then finally, disk to tape is the last use case. And for each one of these, all using the same fictitious customer site of up to 1,200 people and 150 production servers and the requirement to have at least a DR copy sent off once per day, looked at one vendor's specific technology to just do a apples-to-apples comparison across these different approaches. And what we're seeing is that the software as a service model comes up as the lower cost solution in this case. And obviously this is for a pretty big site. You can see that it's a all service type of a fee that's associated with it. You don't have things like manpower being a significant portion like you do with tape. You're going to have obviously WAN transport costs that you might not have in a disk to tape scenario, but you don't have any on-premises software or hardware that can often be expensive to invest in the first place from a CapEx standpoint and maintain overall long-term from an operational expense standpoint. So just kind of summarizing, interruptions are definitely going to happen. It's not just if they will happen, but more likely when they will. You really need to audit what protection mechanisms you have in place today and think about how you need to protect your digital assets. What type of insurance policies do you need to have in place? It may be easier and less costly to deal with protection before you have some type of catastrophe rather than being reactive to that interruption event. So being proactive and taking the necessary steps to prevent and minimize downtime is probably something that you would like to look at. Digital assets are an important aspect of most businesses. So distributing copies of data to an offsite location is an imperative. And a cloud container is a real cost-effective way to maintain offsite copies. and provide a really effective disaster recovery strategy. So at this point, I will hand the reins back over to Chandra.
Thanks, Lauren. Thank you, Lauren, for that introduction. So now let's talk about how we are looking at implementation of disaster recovery from a standpoint of Zmanda customers, and also introduce some of our technologies which enable you to install and configure our disaster recovery solution in the cloud. So before I go into some of the technical details, let's talk about Zmanda for a second. Zmanda is the leader in open source backup and cloud backup software. We protect close to 1 million systems worldwide at this point, and we have more than 1,500 paying customers in about 58 countries. Our strong belief is in open source, open APIs, and open formats. So by providing you with open formats for your backup archives, we give you the control. So you are always in control of your data, no matter what. So regardless of whether you are writing to tape, disk, or cloud, you have full control of your backup archives. We were the early pioneer in cloud backup. In fact, we started offering cloud backup before anybody else. And we are considered the leader when it comes to business level cloud backup. We today have terabytes and terabytes of data stored on the Amazon S3 cloud, but that's not the only cloud we work with. We have been actually working with several public and private clouds. Amazon S3, of course, is our first and primary cloud that we back up to. We have also done work with Microsoft in integration with Azure. And we have also integrated with the cloud software platforms like Parascale or Mezio. So if you are a service provider and you want to offer backup as a service to your customers, you can do so by installing cloud software and then cloud backup software from Zmanda. So when we say cloud backup, we actually mean two things: backup to the cloud, backup of on-premise data to a storage cloud, as well as backup of the cloud. So if your applications are running on the cloud, how do you back them up? And in fact, when we think about disaster recovery in the cloud, that solution is a combination of these two technologies that we have, which is being able to back up your on-premise data to the cloud, as well as being able to back up and recover your applications which are already running in the cloud. So what do we mean by storage cloud? As you know, cloud is a term which gets defined in multiple different ways. By storage cloud, we basically mean an unlimited amount of storage, which is typically available over the internet if it is a public storage cloud. If you are building a private storage cloud, then it is storage available over your intranet. Storage is available on demand and elastic, so you do not have to worry about how much do you want to provision. And this is actually extremely crucial when it comes to backup, because in case of backup, sometimes it is difficult to plan ahead how much data do you really need. For example, you may guess that you may need too much data, but perhaps you will not use that much capacity, so that much capacity will be wasted for several months or even years. Or the worst case is you may under provision. So for example, you may buy a tape library which doesn't have the capacity to be able to back up what you want to back up. So what that means is that you will have to do a forklift upgrade in a few months when you run out of space or run out of capacity. So in fact, under provisioning is the bigger of the two problems, and storage cloud get rid of under provisioning as a problem. Storage clouds are typically available using a RESTful API. So for example, Amazon S3 provides an REST API to integrate with it. So our backup software integrates with these APIs to migrate data from premise to the cloud. And the cost is on-demand cost, so it depends on how much you are using. It typically depends on actual storage and bandwidth used. And since storage cloud is offsite, it is typically ideal for secondary and tertiary storage. Because of latency issues, for most applications, storage clouds are not useful for primary storage. So typically, most environments will use storage clouds for secondary and tertiary storage. So first, let's talk about what are the reasons to back up to the cloud. And in fact, Lorraine mentioned some of these already. There is no capital expense when it comes to backing up to the cloud, especially in the pure backup to cloud environments. If you are not buying any local tape drive or local backup infrastructure, your expense is an operational expense rather than capital expense. And since you do not have to worry about managing local tape drives, backing up to the cloud significantly reduces the cost of infrastructure management, as well as cost of, for example, power and data center space that is required for storing tape drives and tape libraries. In terms of recovery, if you are backing up to tape and shipping tape to a remote site, at the time of recovery, you need to wait for the first tape to arrive before you can start recovery. Whereas in case of cloud, you can have your first backup set come back over the wire right away. Now, this is actually a crucial point, and we will touch on it again. You need to think about how you want to set up your backup sets carefully when you do cloud-based backups in order for your recovery to happen in the time frame you want it to happen. Geographic accessibility is obviously a huge plus when it comes to cloud backup and recovery. You're not tied down with your physical tape vendor, whoever is storing your tape, because, for example, they may not be able to ship your tapes to a particular location that you want to do recovery in. And from a user as well as from us, from a Zmanda perspective, we are able to expand geographically very fast based on cloud-based backup. So here the distinction is between us versus other online backup vendors, for example, like Mozy, who build their own data centers to provide backup. The difference here is that we expand as storage clouds expand. So for example, in fact, today we are making an announcement for backup to Amazon's cloud in Singapore. So today our cloud backup software can back up to 3 continents, US, Europe, and Singapore. So based on compliance reasons, or based on geographic proximity, or based on your personal bias, you can choose which of these 3 cloud locations you want to back up your data to. And this is very unique. This level of flexibility is just not practical when it comes to backing up tapes or backing up to some other online backup provider. So in general, this is the solution which is targeted towards small and medium-sized businesses or departments of larger businesses. These businesses do not have, sometimes even don't have a dedicated IT manager, let alone a dedicated backup administrator. So for these kinds of businesses, you want an extremely easy to use backup solution which will back up to location of your choice without having to worry about media issues. Another feature that cloud backup offers you, which tape-based backup doesn't, is that you can in fact do more with your data. So once your data is sitting in the cloud, you can analyze your data. So for example, some of our customers run data mining applications on their database backup archives, which are sitting on Amazon S3. So now let's look into some of the features that you may want to consider when you are considering cloud backup. One of them is location control, and I already mentioned that. Your cloud backup software should allow you to pick which data center your data should go to. Now, since you are potentially shipping a huge amount of data over the wire to a storage cloud, you need to make sure that data is getting to remote location correctly. And it's not getting corrupted on the way. So having a cloud backup software which has a built-in data integrity check, the software itself checks for data integrity after the data has been transferred to the cloud, is a crucial feature. Another interesting thing to think about is what is the size of each block that you are transferring to the cloud. For example, we chose for various reasons 10 megabyte to be the default block size for our cloud backup software. However, 10 megabyte may not be optimal for you in various cases. So for example, if you are sitting behind a bad link which has a lot of noise, you may want to reduce the block size so that you have less number of retries. On the other hand, if you are sitting on a very high bandwidth link, which can push a lot of data very quickly, you may want to increase the block size to reduce the overhead of chunking your data into blocks. And this is a feature that Zmanda's Cloud Backup support. One very interesting thing when it comes to cloud backup is security. And how do you manage security? One of the crucial ways to do that is encryption. In fact, when we shipped our first generation of cloud backup software, encryption was built in the sense that it was not even optional. Now, a lot of our customers gave us feedback that some kind of data that they are backing up to the cloud is actually public data. So, for example, they were backing up data that was in their public forums or public wiki. This was very important data for them, but just not too sensitive for them to encrypt it. So they actually asked us to make encryption optional when we are backing up data to the cloud. So now it is your choice whether you want to encrypt or not. Of course, for any data that has any kind of sensitivity, we would encourage you to encrypt it before shipping it to the cloud. As soon as you have the notion of shipping important data to a remote data center, one of the things that people worry about is compliance. And you can be compliant by looking at various things. One of them is location. So, for example, if you are in European Union, you may need to make sure that some data does not cross EU boundaries. And even in US, you may want to make sure that some of your data does not cross US boundaries. So our software will allow you to constrain data to a particular location. Also, it is important that the data is going to a data center which is secure and complies with some of the most stringent data center security mechanisms available today. And Amazon S3, for example, has been certified to be compliant with schemes like HIPAA. So when it comes to cloud backup, there are two use cases, and we heard about these two use cases earlier from Lauren as well. One is backup to cloud. This is the pure SaaS model where you're backing up your applications directly to the cloud without any local infrastructure. So this is ideal if you are setting up a new environment and you do not have any existing investment in backup infrastructure such as tape drives and tape libraries, as well as your data set is amenable to this. So as long as your data set can be transferred to the cloud in the time frame that you require to be sent to the cloud. If your data set is too huge or your pipe is too narrow to be able to push this data, for example, in a weekend or in a week, you may need a hybrid mechanism where you're still backing up to a local disk and tape and then pushing to cloud at a different time. And that is actually the second use case here, which is D2D2C, where a user is backing up to local storage, either disk or tape, and then vaulting to the cloud on a different schedule. And a significant number of Zmanda customers do exactly this. In fact, we would say 80% of our cloud backup customers have some kind of local backup mechanism in their environment. So they are either backing up to disk or tape locally, and they are also pushing to the cloud. In many cases, customers don't push everything to the cloud. So they decide some specific backup sets which need to be migrated to the cloud based on some characteristics. For example, they may decide that a particular backup set needs to be able to recover in a remote geographic location, and they will just put that backup set onto the cloud. Whereas other backup sets which only need near-term local recovery can be backed up to a local disk or to a local tape. So this is a very common scenario. And note that in this picture, we are backing up the clients locally on Monday, Tuesday, and Friday, but vaulting to the cloud on Saturday. And this is also an important feature that many of our customers asked for. They wanted to decouple upload to cloud from backup. And this is a crucial point. So what they wanted to do was they wanted to have extraction of data from a database, for example, Oracle or Exchange, separated out from how long it takes to actually move that data over the wire to the cloud. So by separating these two, you can control these two events as independent events. So for example, when you are extracting data out of a live application, you are not bottlenecked by the speed of your WAN. And then you can pick and choose the upload time based on an automated schedule or using a manual operation. So let's now talk about two of our products which back up to the cloud. The first product is Amandla. Amandla Enterprise is based on a very popular open source backup project called Amandla. It's actually world's most popular open source backup project. It currently protects close to 1 million systems worldwide. Amandla Enterprise installs in a data center and backs up to media of your choice. So it supports all modern operating systems like Windows, Linux, OS X and Solaris, as well as all modern applications like Exchange, Oracle, SQL Server, SharePoint, MySQL, and Postgres. So you install an agent on whichever client or platform that you are protecting. You install a backup server on a Linux or Solaris box. The backup server also acts as your media server. So this backup server can write to disk, tape, and or cloud. So for example, you can write to a local disk and to cloud at the same time, or you can write to a disk and then vault to the cloud later. Or you can simply just back up locally. And a bulk of our Amandla Enterprise customers just back up to local tape or local disk. But one of the important features here is that even if you are today not considering cloud backup for your environment, we are confident that you will consider cloud backup soon enough. And you may want to install such a backup software which will enable you to back up to cloud in near future. So the same backup server will enable you to back up to local media as well as to the cloud. The second cloud backup product is called Zmanda Cloud Backup. This is our Windows-based product which runs a single binary on a Windows desktop or a Windows server and backs up that machine directly to the cloud. So this is close to the pure SaaS model that Lauren was mentioning earlier. However, this also enables you to do local backups. So this product also enables you to do backup to a local disk and then upload to cloud at a schedule of your choice. The ultimate destination of backup archives is cloud, but you can keep local backups for as long as you want. And in fact, we support retention policy for local backup independent from cloud backup. So for example, you can choose your archives will stay on the cloud for 1 year, but your local backups will be expired in 1 month or vice versa. ZCB will back up any Microsoft application like Exchange, SQL Server, or SharePoint, and we also back up Oracle and MySQL running on Windows. Of course, we also back up file systems as well as network drives. Note that many of the other online backup vendors specifically prohibit backing up of network drives because it doesn't work with their business model. But ZCB actually enables you to back up as many network drives as you want to the cloud. So now let's come specifically to disaster recovery in the cloud. So this is an example of using Amandla Enterprise for backing up to the cloud and then recovering in the cloud. So what you do is basically the following. You install Amandla Enterprise in your local environment and you set up a virtual Amandla Enterprise server. You set up replication between the two, and we have a product called Amandla Enterprise Disaster Recovery option, which replicates the configuration catalog and backup images from Amandla Enterprise server to the standby Amandla Enterprise server in the cloud. And then you set up virtual machines which are ready to go after a disaster. We will look into this in detail in a second. The other way to back up and recover in the cloud is by using our Amandla Enterprise S3 option, which instead of replicating the backup images actually writes the backup images to Amazon S3 storage cloud, but still replicates the configuration and catalog directly to the standby backup server. So either of those options are available to you. So some of the considerations to make when you are putting together a disaster recovery solution in the cloud. First one is, do you really need the standby VMs to be running all the time? And that really depends on how fast do you want to recover after a disaster. In most cases, our customers choose to shut them down after initial setup. So at that point, they're only paying for the storage cost of each VM, which is minimal, sometimes just a few cents per month, rather than the runtime of each VM, which could be expensive. So, so that's the cost versus recovery time objective trade-off that you want to make. Another important consideration is, do you have the bandwidth to be able to push your data to the cloud? And this is something that you need to figure out based on some benchmarking, as well as I mentioned before, you can optimize this by setting up your backup sets differently from how you would set them up for backing up to tape. So now that you know that you are uploading to the cloud, you may create few different backup sets which have different characteristics on how they should be moved to the cloud with the perspective of bandwidth in mind. So let's now go over the detailed steps of setting up disaster recovery in the cloud. So the first step is to set up backup process to Amazon S3. And as I mentioned before, both Amandla Enterprise and Zmanda Cloud Backup products will enable you to do so. If you have a heterogeneous environment with, let's say, Linux OS 10 and few Windows machines, you will use Amandla Enterprise. If you have a handful of Windows desktops or servers, you will use Zmanda Cloud Backup. Second step is to complete first full backup of applications on your primary site to Amazon S3. Third step is to configure standby virtual machines on Amazon EC2, which is the compute cloud for Amazon. And make sure that these VMs match the OS and the patch level of the corresponding system on your primary site. So at the time of disaster recovery, you do not have to worry about OS or patch level issues. We recommend that you use elastic block storage provided by Amazon for all data volumes. This will enable you to make sure that your data is persistent across reboots. Next step is to install Zmanda backup software on these standby VMs. So this backup software will then do recovery for you in case of a disaster. You need to install the same Amazon S3 certificate that you used in step 1 on the backup server software, for example, Amandla Enterprise, server software that is running on the cloud, or the standby virtual machine which is running Zmanda Cloud Backup. Because you need to access the backup archives that we just created on step number 1, and the only way to access those archives is by using the same S3 certificate that you used on the primary site. The next step is to set up the Amandla Enterprise disaster recovery option if you are using Amandla. So this option will replicate your catalog and configuration from your primary backup server to your standby backup server. And again, it is your choice on whether you want to keep the standby backup server running all the time or not. If it is important for you to be able to recover quickly after our disaster, we recommend that you leave the backup server software running even though you are shutting down the standby VMs for rest of your system. The next step during the setup is to perform a full recovery from S3 to standby VMs. At that point, your VMs are ready to take on the load after a disaster. So at that point, you can take a snapshot of these standby VMs and shut them down. So now your disaster recovery process is all set. We do recommend that you start your standby VMs periodically to perform a catch-up recovery. This has two benefits. One benefit is that your recovery time will be reduced after an actual disaster, and second is that this tests your disaster recovery process automatically. So depending on your time and resource constraints, we recommend that you perform step 10 periodically. So just to summarize, in terms of various products that Zmanda has which are related to cloud backup and disaster recovery, we have Amandla Enterprise which backs up a whole data center to the cloud. We sell an Amazon S3 option for that. We have Zmanda Cloud Backup which backs up a single Windows server or a desktop to the cloud. We also have cloud backup option in our MySQL backup product, which is called Zmanda Recovery Manager, and we had made it intelligent about the cloud. So for example, it can leverage the snapshot feature of elastic block storage on Amazon S3. So here are some of the links if you would like to do further research on cloud backup and disaster recovery. We will also post the presentations from today's webinar on our blog in next day or two. So at this point, we will open up to any questions either for myself or for Lorraine.
I've answered the one. So we got one question asking if Zmanda Backup Server can be a virtual machine.
Okay, I'll take that. So yes, Amanda Backup Server can run on a physical machine or a virtual machine. So in this picture where we say Backup Server running on Linux or Solaris, so either of these could be a virtual machine. In fact, we ship a virtual backup appliance called Zmanda Backup Appliance, which is based on SUSE, which basically installs on a VMware-based infrastructure and would back up again to media of your choice.
Another question. Amazon S3 has a 5 gigabyte object size limitation. Can you back up files larger than 5 gigabytes to S3?
Okay. So that's a good question. So, so remember I mentioned before that we are using REST API to integrate our products with Amazon S3's API, and we actually hide some of these limitations from the end users. So in the behind the covers, what we do is we treat each 5 gigabyte object on Amazon S3 as basically a tape. And since our backup software supports tape spanning anyway, you can back up data of unlimited size onto Amazon S3 cloud. So there is no limitation when it comes to the size of a backup. So actually we have a question here which I would actually like to pose to Lorraine. So Lorraine, we have a question here which says, what kinds of businesses do you feel will move to cloud backup initially?
So I think the opportunity is for organizations whose infrastructure it might be a little bit dated and would like to refresh their capabilities and move to something that was more efficient than what they're doing on premises. Potentially that's organizations that are using tape media, for example, on site and are trucking those tapes to an offsite location, or maybe they stay in the trunk of the car. But I also think it's an opportunity for larger organizations that don't have adequate coverage at remote and branch offices, for example. That's another great use case where you don't necessarily have on-site staff, and it's often, the backup of data at those remote locations is often something that's less efficient than what you're doing in the data center. But then additionally, there's definitely going to be opportunities for companies of any size in their data center where they're looking to create that disaster recovery in the cloud scenario where you don't have that second copy that exists off-site because you don't have the feasible location to act as a second site, or it's not something that you've had the time or money to invest in implementing.
Okay, thanks.
Thank you. Okay, we've got a question from Mike Johnson. Mike is asking about, can we convert the utility P to V?
Okay, so the question here is, can we go from physical to virtual? So in fact, if you saw the disaster recovery picture that we had shown before, in effect, what you are doing is you are taking physical machines and taking them to virtual machines on the cloud. So what this means is that basically in terms of where you are recovering to, those can be physical or virtual machines regardless of the source. Now, we should also point out that we recently started shipping our VMware option, which basically backs up virtual machines at physical image level. So instead of installing an agent within the virtual machine, we talk to VMware using their API and back up a whole image of the virtual machine, which also helps in disaster recovery because you don't have just the data, you also have the whole operating environment to go with after a disaster happens.
Okay, great. We have another question here about pricing. How does Zmanda charge for backups to Amazon S3?
Okay, let me take that as well. So we have two different models. With Amanda Enterprise, we simply ship an Amazon S3 option, which is an annual fixed cost, which is just like subscription. So we sell Amanda on a per protected system basis, and we sell Amazon S3 option as a one-time subscription. And then you buy your own Amazon S3 certificate and pay directly to Amazon based on their price to the end users. With Zmanda Cloud Backup, we have a slightly different business model. The software itself is, pretty much free. It's $5 per month, and then you pay us 15 cents a gigabyte for storage and bandwidth. So, in fact, as of tonight, we are reducing the cost of ZCB to 15 cents a gigabyte. So, if you are in US, it is going down from 20 cents to 15 cents, and if you are in Europe or Asia, it is going down from 25 cents to 15 cents a gigabyte. Okay. So we actually have another question for Lauren. Jim is asking, can you estimate the size of the cloud storage market and related growth for various applications such as D2C or D2D2C? I don't know if you have such data points, Lauren.
Yeah, I actually don't have specific market sizing, but I can tell you that there's been a tremendous increase in the use of cloud storage for data protection purposes. And one of the research points that we looked into most recently is what are the future plans for the different types of medium that you use for backup and data protection. And what was interesting is that we are seeing a decline in the use of tape, on the order of 20% internally in an organization, up to 60%. And it depends on the size of the organization and whether or not they have regulatory compliance and stuff. When we look at Offsite, we're seeing the same trend of a decrease in the use of tape. And where we're seeing an increase is either in a disk-to-disk-to-disk scenario for those companies that have a second site. And for those that don't, we're seeing a 40% increase in the use of cloud. And so over the next 2 years, that trend of drop off of tape, increase of disk and or cloud, with cloud actually showing the highest percentage of increase expected over the next 2 years. So I hope that answers the question.
Okay, so actually here is another question from Lionel. When setting up for cloud backup, does server have to sit on the WAN? Would we need two network interfaces, one for external and one for internal net? Okay, so let me rephrase the question and then I'll answer it. So the question is, what is the interaction between backup server and WAN? And how do you actually set up the network configuration? Backup server certainly needs to have internet access. Since you are pushing data to a public storage cloud, you need a backup server to be able to talk to, in this case, for example, the Amazon S3 cloud. However, it does not need to be sitting directly on your outside WAN, so you can configure your network appropriately. Now, from a security perspective, it would be a good idea to separate out that particular link, not just from a security perspective, but from a performance perspective as well. Because what you may be able to do is you may be able to use a network shaping tool to figure out how to manage the bandwidth between your backup server and the cloud. By the way, just another point to note, in the latest Zmanda Cloud Backup 3.0 product, we also support WAN throttling as a feature. So you can throttle how much bandwidth you are going to be using. Another recommendation that we have is that you may consider using a non-SLA based uplink for your backup traffic. We in fact do that here at Zmanda. So we have an SLA based internet connection which we use for our day-to-day employee activities, but we have a consumer class link that is coming in which we use for our backup upload, and which works perfectly. The bandwidth is really good, and if it goes down, let's say once a year, our backup software is intelligent enough to pick it up next year. So it's not a big problem for us.
Okay, we've got another question for Chander. what is the format of backup archives for Zmanda Cloud Backup?
Okay. So this is another important question and something that you should definitely think about when you're backing up your data anywhere. What is the format of your data in your backup archive? Can you actually get to it 10 years from now or 30 years from now? We have some state and federal agencies who have retention policy of 30 years, for example. So we always back up in an open format. And the format depends on the platform that you are backing up. So in case of Windows, the format that we use is zip. So if you looked at a backup archive of the Zmanda Cloud Backup, it is actually a zip folder, and you can point one of your zip-friendly applications to that archive and open it up and do whatever you want with it. So there was another question about how Zmanda reduces the size of dataset. So we actually use several various compression mechanisms before we ship data to the cloud. And again, in the latest Zmanda Cloud Backup product, we actually let you choose kind of compression that you want to do. So you have a choice between fast but not too tight backup, or other way around. Potentially backup which is the most space saved, but potentially which take more computing resources before shipping to data. So that slider is in your control. So Cody is actually asking a question about a demo. So today we have run out of time for demo, but we will send a note to all attendees about another event where we will provide a live demo of Zmanda Cloud Backup software. Please, any other questions, please feel free to ask them on the chat window. Okay, so in that case, we will wrap it up. Thanks a lot for joining us today. We see people have joined us from all around the world. Some of the time zones are probably in the middle of the night. So specifically to those folks, a special thank you. We will send a note about the recording of this webinar to all of you, as well as a link to the slides. And finally, I would like to personally thank Lauren for joining us today.